Okay, everyone. So let's go on to our second and third type of problems today. They go hand in hand. So this is why we are doing two types of problems in one session, because it's literally just flipping over a conversion factor in order for us to get the answer for these problems. So last session we did mole to mole, so we're done with that. And hopefully everyone understood it and you were able to work the practice problems and submit your graded assignment. So today we're going to be looking at moles to grams and grams to moles, okay? So we're going to go ahead and just kind of launch right into a problem because I think that that is the best way to address these. So we're going to start with problem type number 2. And problem type number 2 is going to be a mole to gram problem. Okay, so for this problem, you are going to have your periodic table. So I'm going to give you just a second to get your periodic table out so that you can get to it so that you can work these problems. So take just a second and go grab it. Okay, so now that you've got your periodic table, you've got your calculator, and you've got everything to go, let's go ahead and get started working some of these problems. So last time when we did mole to mole, it was just a one-step problem, okay? Mole to gram is going to require us to do 2 steps. So I'm going to start with just a typical problem that you would see. So a scientist is going to decompose hydrogen peroxide in the lab. So when he decomposes hydrogen peroxide, it forms water and it also gives off oxygen gas, O2. So I'm going to give you just a second because just like before, we have to have a balanced reaction. So if you want to take a second to balance it, just pause the video. So to balance this, we put a 2 and then a 2, and now it is balanced, okay? So let's just say that a scientist starts with 1.840 moles of H2O2 and wants to know how many grams of water he will have form. Okay, so we have our scientist. He's starting with 1.840 moles of hydrogen peroxide, and he wants to know how many grams of water he's going to form. Okay, so right here, we will see our given. So just like in our last video, I'm going to go up here and write 1.840 moles. And I noticed some of y'all think that that's kind of a wasted step, but the reason why we do that is because as the problems get a little more advanced, this gives you a starting point, and then by writing what your unknown is, it gives you an ending point. So they want to know how many grams of water he's going to make. Okay, so this is different because before we just went mole to mole, used a mole ratio. But this time we're going to have to do something a little bit different, okay? So right here, I'm going to start with my given, 1.840 moles of hydrogen peroxide. And then I'm trying to get to water. So to get from hydrogen peroxide to water, I need to use my mole to mole ratio. So I have 2 moles of hydrogen peroxide, and I have 2 moles of water on top. And I put my hydrogen peroxide on bottom because I want to cancel it out. So I'm left with moles of water, but I'm not done. They want me to find grams of water. So in order to do that, I have to convert moles to grams. So how in the world do I convert moles to grams? Well, we know that to go from moles to grams, we have to do molar mass. So I'm going to find my molar mass of water. So I have 2 moles of hydrogen, which is going to give me 2.02 grams per mole. And then I have 1 mole of oxygen. So I know that the molar mass of water is 18.02 grams per mole. So now that we've become an expert on this, you don't have to write all of this out. You can do it over to the side and put it in there, okay? So now I'm going to put this in, and I need to put 1 mole of water on bottom, and then I'm going to put my grams on top. So now moles cancel out. So now I'm going to run it through my calculator. So I take my calculator and I'm going to say 1.840 times 2 times 18.02, and then I'm going to divide by 1. I'm going to divide by 2 and then divide by 1. And I get 33.1568. Okay. Now, I have to go look at my given 1.840 moles. That's 4 sig figs. So 1, 2, 3, 4. 6 rounds it up. So it's going to become 33.16 grams of H2O. And you have to put it in sig figs, and you have to show me your units and circle it. Okay, so right now you may be a little frustrated already, going, I have no idea how she did that. So I'm going to show you a quick little skeleton when working these types of problems. So back to mole, problem type 1, we learned that you take your given, which was in moles, and then you do your mole to mole ratio. Okay, so this is your mole ratio. And then that gives you your answer in moles. Okay, so for this one, we started with moles and went to grams. So this is what we call a moles to grams problem. So our given was in moles. We're going to put in our mole to mole ratio. And then we're going to put in the molar mass. And this is the molar mass of the unknown. Okay, so basically it's given times mole ratio gives you moles. This one is given times mole ratio times molar mass gives you grams. Okay, so that may help you out if you get a little lost on, it kind of gives you a roadmap. All right, so on this one, we started with moles, we put in our mole ratio, then we put in our molar mass, and we got this. So let's work one more of a mole to gram, and then we'll look at the next type, gram to mole. So I want to go back to our photosynthesis problem that we did last time. So we have CO2 plus H2O yields glucose and oxygen. Okay. And this time, we need to balance it, just like we did before, 6, 6, and 6. But this time, they're telling us we have 3 moles of water, and they want to know how many grams of glucose are produced. So this is a mole to gram problem. So using our little road map, I'm going to start with my known or given in moles, 3.00 mole of H2O. Then I'm going to go to my mole ratio, so it's 6 to 1. So 6 mole of water on bottom, 1 mole of C6H12O6 on top. And then I need to convert these moles to grams. So to do that, I need to find my molar mass. So I have 6 times 12.01, 12 times 1.01, and 6 times 16. So that gives me 72.06. And this is going to be 12.12. And this is going to be 96. And then I add them all together. And I get 180.18 grams per mole. So I'm going to go up here and put this in, 1 mole, C6H12O6, and there's 180.18 grams C6H12O6. So now I can cancel out all my values that are like, and now I run it through my calculator. So to do that, I'm going to say 3 times 1 times 180.18 divided by 6 divided by 1, and I get 90.09 grams of C6H12O6. And my given had 3 sig figs, so 1, 2, 3, and that's going to round it up, so it's going to become 90.1 grams of C6H12O6, and that's my answer. Okay, and if you look back at that little skeleton, you'll see given, given, mole ratio, molar mass, and that's your answer. Okay. All right, so the same exact type of problem as far as what we're starting with and ending with in the units. It's the same thing, we're just going to flip-flop it. But I put this as problem type number 3. So for problem type number 3, they're going to give us grams to begin with, and we're going to go to moles. Okay, so on this one, we're going to use our a formula that looks like this. NH3 plus O2 yields NO plus H2O. So this is the initial reaction that takes place when we manufacture nitric acid. Before we can get to nitric acid, we have to oxidize ammonia, NH3. So first thing we're going to do is we're going to balance this. So if you want to pause it, So that way you can balance it on your own. You can do that right now. Okay, so to balance this one, it's 4, 5, 4, 6. Okay, so they're going to tell us, they want us to work a couple problems out of this one. So the first problem is, if the reaction is run using 824 grams of NH3 and oxygen in excess, how many moles of nitrogen monoxide are formed? Okay, so this is going to be our problem. And once again, this oxygen in excess, like last time, just wait on that. We're going to get to that in a couple more videos, okay? So we're going to start with our given 824 grams of ammonia. So I'm going to go write this up here. Okay, and then they want to know how many moles of NO are formed. So here's our unknown moles right there. So just like before, we are going to start with our given 824 grams of NH3. And I'm going from grams from ammonia to nitrogen monoxide. And normally I would do a mole ratio, but notice I don't have a mole here to cancel out. So before I can use my mole ratio, I've got to convert these grams to moles. So basically we're working the last problem type backwards. So I'm going to go find my molar mass of NH3. So nitrogen is 14.01, and then 3 hydrogens with 3.03. So you get 17.04 grams per mole. So I'm going to go put this into my problem. And so I'm going to put 17.04 grams of ammonia on the bottom. And then that leaves 1 mole of ammonia on top. So now my grams cancel out and I'm left with moles of ammonia. So now I can bridge the gap from ammonia to nitrogen monoxide. And I'm going to do that with my mole to mole ratio. So I have 4 moles of NH3 and 4 moles of NO, and that cancels out ammonia. And I'm left with moles of NO. And look, that's what we're trying to find. So now I just run it through my calculator. So I'm going to say 824 times 1 times 4 equals, divided by 17.04 equal, divided by 4 equal, and I get 48.35681 moles of NO. And so I have 3 sig figs in my given. So this needs to be 3, 1, 2, 3. That's going to round it up to 48.4 moles of NO. And that's my answer. Okay, so before when we were doing those skeletons, it looks like this. Now we're just going backwards. So on the third one, when we're going from grams to moles, this time we have our given is given to us in grams. So we have to do the molar mass of the known. So that would be mole over gram. And then we do our mole ratio, which would be mole over mole. So basically you're just saying given in grams times the mole ratio of the given, molar mass of the given times the mole ratio. And that's going to give your answer in moles. So the given in grams times the molar mass of the given gives you the mole ratio. Okay, so it's kind of like we're just flipping things around a little bit. Right here, you ended up with grams. This one you're starting with grams. If you look, grams, MR given. This is going to be grams, MR mole, because your given was in mole. Okay, so it's just a reverse. So let's go back to that same problem or same formula. Sorry, same reaction. I'm going to write it down so I have a little more room again. You probably have room. So 4NH3 plus SO2, I'm sorry, 5O2 yields 4NO plus 6H2O. So same reaction, but we're going to work another problem with it. This time, I want to know if I have 824 grams of ammonia, how many moles of water can I make? Okay, so just like before, we're going to start with our given. And then I've got to find my molar mass of my given, but luckily we did that last time. So I know that it's 17.04 grams of ammonia and 1 mole of ammonia. So now I have moles of ammonia, so now I can bridge the gap with that mole ratio. 4 moles of ammonia to 6 moles of water. So those cancel out, and I'm left with 6 moles, and I was looking for moles, so that's where I know how to stop. So now I just run it through my calculator. 824 times 6 equals, divided by 17.04 equals, divided by 4 equals, and I get 72.5352 mole. And I have 3 sig figs, 1, 2, 3. So 72.5 moles of water is my answer. Okay, so as you can see, it's not difficult to work these problems. You just have to know where you're starting and where you're going to, and then just follow the steps to get you to that point. Okay, now on the Google Classroom, once again, when you go to the Google Classroom, you're going to see under the mole to mole, under classwork, look for mole to mass problems. And once again, you're going to find here are some practice problems, and I have provided you with the answers to those practice problems. So that way you can see if you're doing it correctly. Do these two first, and make sure that you know what you're doing. And if you have questions, you can ask them. And then you can go and work the one for your grade, okay? And once again, just type your answers into the Google Doc and submit pictures of your work, okay? So that's it for our mole to gram and gram to mole problem. And so our next one, we will look at gram to gram. All right, good luck, and let me know if you have any questions.